Hi guys, welcome back from spring break. I missed all of you so much. Today we are going to move on from the counting principle and learn more about combinations. Some updates and announcements. Don't forget that e-learning is required every day, Monday through Thursday. If you have questions, make sure you reach out to me at vmcneely@riversidehighschool.org. One thing to notice is you need to be submitting your work with the correct teacher. Ms. Lockhart and Ms. McNeely have different links for assignments. Some of you are submitting your links in the wrong place, so make sure you're on Mrs. McNeely's haiku page, not Ms. Lockhart's haiku page. All assignments for now can still be completed. Ms. Dorsey is talking about switching this up and changing the deadline. So if you still have things from quarter 3 that you'd like to do on a separate sheet of paper and email me, or any e-learning from this entire time, you can go back and do any of that now, and I'll get all those grades updated this week. I wanted to let you know about how I'm going to be grading IP. It took me some trial and error to figure out, but I think I've got it. IP will be graded for correctness, not completion, which is what I've been doing the whole time. Remember, you don't have tests, so I have to have some way of knowing how you're doing on this material. Partial credit will still be given, and you can always attend office hours and just go ahead and redo any IP that you aren't happy with. So if you don't do well, get on office hours, we'll work on it together, you can take it a second time. All IP will now be worth 10 points in the gradebook, regardless of how many points it actually is worth on the assignment. So for example, if you get 27 out of 35 possible points on the Google form, here's what I will do. I will divide 27 by 35, which gives me 0.771. I'll move the decimal point one place to the right and round. And so your grade becomes 7.7 out of 10 in the gradebook. I'm doing this so that you can more easily see how you're doing. It won't change your grade much in either direction. But this way, if you get a 9 or above, you'll know that's an A. An 8 will be a B, a 7 will be a C, and anything below that is an NG, and you should think about redoing that. At this point, you need to be using your Riverside email address. That email is firstname.lastname@riversidehighschool.org. This makes it much easier for you to access materials. And if I need to contact you, I need to know that you are checking that email. If you are not using that email and don't know how, you can email me today and we can set that up. We can probably get that fixed today or tomorrow. From now on, all Google Forms will require you to use your Riverside email address. Don't forget about office hours. Office hours will be held Monday through Thursday from 11 to 12. The link can be found at the top of the haiku page. If you need more one-on-one help, go ahead and just email me. We can get together in a private office hour. That way you're not sharing your time with other people. I wanted to give a shout out to Ely, Andreas, Michelle, Creighton, and LJ for attending office hours before spring break. I miss all of your faces, so even if you don't need help, stop by and say hello. Hey, all you cool cats and kittens. Anyone watch Tiger King over spring break? All of my group texts at this point have now just become Tiger King discussion groups. What are you watching or reading right now? Share in the struggles and celebration box when you go to the IP on Haiku. Before we start, I want to give you some strategies for success. Number one is you need to complete these lessons in order. If you have not yet done any previous math e-learning assignments, you want to go back to the beginning and work your way back from a month ago. You don't want to dive into the middle because you're going to be very confused. You also want to make sure that you're watching your video. Based on some of the responses I'm getting on the IP, it doesn't seem like everybody is watching the video before they do the assignment. Also, you want to make sure you take notes to refer to while you complete your assignment. Do you have a pencil and paper out now? If not, go ahead and pause this video and go get your materials. When the video says to pause and try the problems on your own, you need to do it. You need to practice before you complete the assignment on your own. If you're unhappy with your grade after you submit your assignment, just email me and resubmit for a better grade. Remember, assignments are now graded on correctness, not completion. If you just write IDK or you leave blank, you get a 0. There was an error on the last IP on the counting principle on number 10. I did not count that question against you, but I wanted to show you why it didn't work. Then we'll do some practice on simplifying rational expressions in the bell work today. So for this one, we can't just start canceling out. This is a trinomial divided by a binomial. We need to factor. We need to cancel factors, not terms. So we're going to start by factoring, which is where we multiply a times c. So that gives us -8. And we're looking for numbers that multiply to be -8, but that's a lot of options. 1 and 8, 2 and 4, some combination of negatives there. So we need a better way. We now need to look at two numbers then that multiply to be -8, but add to be -3. There's no way for this to work Negative 8 plus 1 gives me negative 7. Negative 4 plus 2 gives me negative 2. This is not factorable. So my answer just stays the way it is. This is simplified as far as it can go. There is nothing else to do. So we should have stopped there. I want you to go ahead right now and pause the video and complete the bell work below. Remember, it's really important to keep practicing these problems so that you don't forget everything while we're gone. Go ahead and pause this and try these now. Welcome back. You should have factored this top trinomial here before you started. So remember, we're going to multiply a times c, so 2 times 3 becomes 6. We're looking for two numbers that multiply to be 6. Well, that's 1 and 6, or 2 and 3. But I need these to add to be negative 7. Well, 2 plus 3 is 5, 2 minus 3 is 1. That one's not going to work. 1 plus 6 gives me 7, but I need these to be negatives because negative 1 times negative 6 gives me positive 6, and negative 1 plus negative 6 gives me negative 7. So now I'm ready to factor. I keep everything exactly the same, except I need 4 terms to factor. So I'm going to replace the negative 7 with the negative 1 and the negative 6. Now I'm ready to factor by grouping. I'm going to separate these into two groups. And I'm going to factor out their greatest common factor. 2x squared and negative 1x are both divisible by x. That leaves me with 2x minus 1. Negative 6x and 3 are both divisible by 3. That leaves me with negative 2x plus 1. These are supposed to match, and they don't. I notice that the signs are wrong, so instead of factoring out a positive 3, I'm going to factor out a negative 3. Now, negative 6 divided by negative 3 is positive 2. Positive 3 divided by negative 3 is negative 1. Now the two parentheses are matching. The common factor is 2x minus 1 over x minus 3, which is where it comes from, these two. Now don't forget, the original goal was to divide, so this is x minus 3 times x plus 4. Now I can see there's two common factors, x minus 3 and x minus 3, which leaves me with 2x minus 1 and x plus 4. Can't just cross off the x's because those are not factors, those are terms. If you haven't already done number 2, go ahead and pause the video now and try number 2 on your own. If you have, we're going to go ahead and go over this now. You should, again, be factoring this trinomial. So remember, there's an invisible 1 here. Negative 15 times 1 becomes negative 15. I'm looking for two numbers that multiply to be negative 15. Well, I could do 1 and 15 or 3 and 5. But I need them to add to be 2. So let's think about where we could put the negative to make that happen. Let's see. The larger number should be a positive because the 2 is positive. Negative 1 plus 15 does not give me 2. Negative 3 plus 5 does give me 2, so those are my magic numbers. Factor the trinomial, I'm just replacing the 2 with negative 3 and positive 5, which add to be 2 anyway. Now I'm ready to factor by grouping. Group the first two, group the second two. Factor out an x, so we get x minus 3. Factor out the 5, so we get x minus 3. The magic happened. These are we have a common factor of x minus 3, and left over we have an x and a positive 5. So remember, the whole goal was to cancel the common factors. So on the top we had x plus 5, and we had x minus 3 times x plus 5. The x plus 5's cancel. Remember, anything divided by itself is 1, so we don't just have some blank over x minus 3, we have 1 over x minus 3. And you're done there. Nice job. I want to start with some review on the counting principle. Last time we learned about the counting principle. If you haven't already done that lesson or didn't do well on that assignment, I encourage you to stop here, go back and complete that lesson, and submit or redo that assignment, as you will need those skills today. Here's an example from the last IP. Let's look at two ways to do this, with a tree or using the counting principle. So you're looking at used cars. You find some with the following options: colors in black, white, or red, with or without air conditioning, and with or without automatic transmission. How many different cars are available? Well, if we do this using a tree, there are 3 different options for colors. We could either get a black car, a white car, or a red car. Then we could get this with or without air conditioning. So if we get a black car, then we could get air conditioning or no air conditioning. If we get a white car, again, air conditioning or no air conditioning. A red car, air conditioning or no air conditioning. Then we have an option for with or without automatic transmission. So if we get a black car with air conditioning, we could either get automatic transmission or no automatic transmission. If we get a black car with no air conditioning, we could either get automatic transmission or no automatic transmission. And we just continue this out for each branch. And it starts to get a little messy. And then the way to count the number of possibilities is to look at each one. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So doing this using a tree, we get 12 options. But pretty quickly, this gets to be just unmanageable. It already almost made me make a mistake because I almost forgot to circle that one right there because it got hidden next to the other one. There is a better way. If we look at the colors of the car, so colors of the car, there are 3 different options. If we look at air conditioning, there are 2 different options. And if we look at automatic transmission, there are 2 different options. Instead of doing that tree, we can just do 3 times 2 times 2, which again gives me the 12 choices. As your teacher, I never do a tree. It's useful for you to see where all the choices come from, but I never use a tree. I almost always will use this counting principle. The counting principle is just where you multiply your options together. Today we want to extend our learning about using the counting principle to discuss permutations and combinations. Permutations and combinations refer to the numbers of ways in which objects from a set may be selected. When order is important, this is called a permutation. When the order matters, that's a permutation. For example, you say that your locker combo is 5432. You enter 4325, same numbers, into your locker. It won't open because it's a different ordering. Locker numbers aren't actually combinations. Locker numbers are actually permutations. Next time we're going to learn about permutations, but today we will focus on times when order isn't important. This is called a combination. So everything we're doing today is going to be times when order is not important. It's important that you're able to recognize the difference between a combination and a permutation so that you know how to calculate it. Remember, if the order is important, then this is a permutation, not a combination. Sometimes when we need to know the number of options for something, we can just go back to the counting principle and do that instead. In a race in which 6 automobiles are entered, there are not ties. In how many ways can the first 4 finishers come in? Excuse me. This is actually a permutation because order is important. The first 4 finishers are an order, and so that's a permutation. Remember, if the order is important, again, this is a permutation, not a combination. Or we might just be using the counting principle for these. The model of the car you're thinking of buying is available in 9 different colors and 3 different styles: hatchback, sedan, or station wagon. In how many ways can you order the car? Well, this is just counting principle because all we're doing is counting up the different options. We're not selecting from a group. We're not putting things in any order. This is a counting principle. Remember, again, if order is important, then this is a permutation, not a combination. Or maybe we can just count the number of options and multiply, in which case we're using our counting principle. Here is the type we're going to be working on today. A book club offers a choice of 8 books from a list of 40. In how many ways can a member make a collection? We're not ranking the books. We're not listing the books in order of favorites. In how many ways can a member make a collection? This is a combination. We are selecting 8 from a group of 40. We are not trying to find how many different options of books there would be if we used all 40, which would be counting principle. We are selecting just 8 books from a group of 40. All right, let's go ahead and stop the video here and let's go on to video 2.